a couple different types of quadratic equations that you need to solve in this first section, or in this section 5.2. The first is a problem like this. All of the first set of equations that we're going to be looking at are equations that rely on using the zero product rule. The zero product rule states that if A times B equals 0, then either A equals 0 and or B equals 0. And so it allows you to solve for variables in this way. So in this particular set of problems, what you would do in all of them is you'd move all your terms to one side and set it equal to 0. Then you'd factor. So you're going to set equation equal to 0, factor, and then apply zero product rule. Okay, and so this is going to be true for many different types of equations. Okay, so the first type that we'll look at is one where when you set your expression equal to 0, which is already done here, you look to factor. The only way that you can factor this is to remove common factors. So between these two terms, the common factor is 3x. When we remove that, you're left with a 2x and a plus 1. And then it's just a matter of applying the zero product rule. You can either apply this manually. You can actually take your factor 3x and set it equal to 0. And you can take your factor 2x plus 1, set it equal to 0, and then solve each of these. So we divide by 3 here. Here we subtract 1 and divide by 2 to get your answers 0 and negative 1/2. Realistically, you guys should be comfortable just setting these factors equal to 0 mentally. And so if I ask you, based on this factor 3x, what value of x would make this equal to 0? 0. In this second factor, 2x plus 1, what value of x would make this factor equal to 0? And the shortcut is you just take the opposite of the constant, so negative 1, divide by the coefficient 2. And the last thing that you would do is when you write this online is just make sure that you write from the smallest answer to the largest. All right. All right, you may be asked to solve a little more complex type of problem that requires more than just removing common factors. Okay, so here's an example like that. If this was your expression, the first thing you do, set your equation equal to 0, which is already done. You look to factor it. So again, when you factor something, step 1 is to remove any common factors. Are there any common factors between these three terms? Yeah, an x squared, right? So we can take out an x squared from each term. You're left with 2x squared minus 15x plus 18. That's still set equal to 0. And now you have this trinomial. The leading coefficient is something other than 1, so you either reverse FOIL or you rewrite the middle term. Okay, so I'm going to go through the steps for rewriting the middle term. Take my leading coefficient times my constant. 2 times 18 is 36. What two factors of 36 give you a sum of negative 15? Minus 12 and minus 3. So if I rewrite my middle term as those, drop my first and last terms down, and factor by grouping. When I do that, I can remove a common factor of 2x, leaving x minus 6, and from the second pair of terms, remove a common factor of negative 3, leaving an x minus 6. And if I've done that right, I should have a common binomial factor, which is x minus 6. The remaining factors of 2x and negative 3 form the terms of my other binomial. And do remember, you have to bring this this early factor that you removed out as well. Okay, once you get to this point here, you can set each factor equal to 0. So based on this first factor, what value of x gives you a 0 for this first factor, x squared? 0. What value of x gives you a 0 for this second factor? 6. And what value of x gives you a 0 for this last factor? opposite of the constant, positive 3 over the coefficient 2. So again, just reorder these from smallest to largest. So 0, 3/2, and 6 would be your solutions. Okay. Questions on that process? All right, let's take a look at one last example that follows this, only follows this rule. All right, so again, step 1, set your equation equal to 0, already done. Step 2, you're going to factor. Well, are there any common factors you can remove from these 4 terms? No. So you look for any special factor forms. Well, 4 terms don't really have any special forms other than if you have 4 terms, look to factor by grouping. Right? It's possible that that will be the case. If you look at this first pair of terms, you can remove a common factor of x squared, leaving you with x minus 3. In the second pair of terms, you can only remove the sign. Whether it's a positive 1 or negative 1, I would recommend you write that. So negative 1 is the factor removed. When you remove that, the negative x becomes a positive, and the positive 3 becomes a negative. And then it's just a matter of removing your common binomial factor. The remaining factors of x squared and minus 1 become the terms of our other binomial. Now, we still aren't complete, or we still aren't finished yet. We can still factor this further. X squared minus 1 fits a special factor form, so you can remove, or you can factor this as the difference of squares, factors into the sum and difference of the bases being squared. And now it's just a matter of setting each factor equal to 0. So what value of x gives you a 0 in this first factor, in the second factor, and in the final factor, 1. So when you rewrite this from smallest to largest, you get your solutions. All right, so try this one on your own, just really quickly. And see if you can solve it following these same rules. Okay, it's pretty straightforward. Set it equal to 0, already done. Look to factor it. This is the difference of 2 squares, so we can factor it into the sum and difference of the bases being squared, which are 3x and 1. Take the sum and the difference. And there's your factors. Set each factor equal to 0. So what value of x gives you a 0 for your first factor? Opposite of the constant, negative 1 over the coefficient 3. And in the second factor, opposite of negative 1 is positive 1 over the coefficient 3. So those would be your factors.